This lesson is translating verbal expressions into variable expressions. Basically, that means that we're going to take phrases that are written in English words and translate those into mathematical symbols so that we can work with them. Just like with any translation, it requires a command of vocabulary items to be able to translate from one language into another. We are translating from the English language into mathematical language. I have written for you some words that you should become familiar with if you're going to be successful in translating these verbal expressions. Let's take a look at some of those. I have listed here words that mean add. Some of these words will be very familiar to you. Some of these you perhaps have not used. The expression more than. If you say that you have 3 more than someone else, then you would have 3 added to the amount that the other person has. Of course, you know that the sum of means that you are adding. Total means that you are adding. Increased by, if you increase something, you add to it. Of course, added to is self-explanatory, and so is plus. We're going to find as we look at these verbal expressions, when we see these types of words, we're going to translate those as a plus sign. Words that mean subtract. Less than. If you have less than someone else, then you would need to subtract from what they have to find the amount that you have. Of course, subtracted from has the word subtract, so we know that that means to subtract. The difference of, or the difference between, the word difference is implying that we subtract. Decreased by, if you decrease something, you subtract from it. And then minus. All of these types of words would be translated as a subtract symbol in mathematics. Words that mean multiply. Of course, times we use all the time, so you know that when you say times, you are multiplying. The product of. The word product means the result of a multiplication problem. So if you're finding the product of 2 things, you are multiplying those. Now this word of is very important that you learn that this means to multiply. The word of is used primarily when you are working with percents or with fractions. If you say 1/2 of, then you would translate that as 1/2 times. If you say 30% of, then you would be multiplying 30% times something else. So you really need to be aware that that word of is translated as times. Of course, we often say the word twice. Twice is another way of saying 2 times. So when you say twice a number, you are implying that you are multiplying that number by 2. And of course, multiplied by is rather self-explanatory that you are doing multiplication. Words that mean divide. The obvious one, divided by. The quotient of, if you remember learning that the quotient is the result of a division problem. So when you see the quotient of, you know you are dividing. Now, this word ratio, the ratio of. A ratio is a division problem. So you need to know that if you are doing the ratio of 2 numbers, you are dividing those numbers. And then our last group of words here are words that mean a power. If you say the square of, you are saying that you have a number raised to the 2nd power. The cube of means that you have a number to the 3rd power. Of course, you can also use the words like the 2nd power, the 3rd power, the 4th power, and so on. All of these types of expressions means that you will have an exponent. Now that we have looked at the vocabulary that's involved in translating expressions, we're going to look at some example problems. I want you to learn to translate very carefully from the words into the mathematical symbols. Let's take a look at our first example. Our instructions are to translate into a variable expression. Let's look at this first example. 5 times the sum of x and y. If you start at the very beginning, notice you have 5 times. That word times means that we're going to multiply. There are several ways that we have of expressing multiplication. We can use the little dot, or sometimes we use the little symbol that looks like an X. However, in algebra, I would encourage you not to use that symbol because then it's very confusing and you're not sure if you mean the variable x or if you mean the times symbol. Another way that we have of indicating times is using parentheses. You'll find that a lot of times in algebra we like to use those parentheses to indicate multiplication. Now, part of this translation is understanding exactly what we are multiplying. Sometimes I like to have my students do this. This word times means we are multiplying. On this side of the word times, we have a 5. Right on the other side of the word times, we have the sum. We are multiplying 5 times the sum of something. So let's indicate our multiplication. We're going to put down our 5. We will use a parenthesis to indicate the multiplication. Now we need to decide what goes inside that parenthesis. We are multiplying the 5 times a sum of 2 other quantities. So inside this parenthesis will be a sum, which we know is an addition problem. Now this sum is the sum of x and 7. So we will put x plus 7 inside the parenthesis. Now let's check to see that our expression is saying exactly what the words say. 5 is times the sum of x and 7. Number 2, we have the quotient of y and the sum of z and 8. Again, this first word right here, the quotient, is indicating that we are dividing. As with multiplication, there are several symbols that we can use to indicate a quotient. Most of the time in algebra, we like to use the fraction bar to indicate a quotient, and that's the way I'm going to write this expression here. Now let's see what we're doing this quotient of. We have the quotient of y and the sum. So we are dividing y by a sum. Let's put y down. We will use our fraction bar to indicate our quotient, and then we are dividing by this sum. So down here we're going to have a sum, a plus, between z and 8. We have the quotient of y and the sum of z and 8. Number 3, the sum of the square of x and 12. We have a sum here. We know we're going to be adding 2 things. The sum of what? The first thing that we have is the square of x, and then we are adding to that the 12. The square of x is indicating that we have a power on x squared. We are adding the square of x and the 12. Number 4, the product of -2 and the square of y. We are looking for a product. That means that we are multiplying. What things are we multiplying together? Let's look for that word and. We are multiplying -2 and the square of y. Let's write -2. We can use a parenthesis if we want to indicate that we're going to multiply. We're multiplying by the square of y, which indicates we have a second power on our y. So we could write -2 and in parentheses y squared. Now in this particular instance, the parentheses are not entirely necessary. If we simply write -2 y squared with no parentheses, we've learned that a number written right beside a variable means that we're multiplying when there is no symbol written down. We also know from the order of operations that we would do the exponent first before we would do this multiplication. So we are still multiplying in this particular example here, -2 times the square of y. So you could write this expression or this expression and be correct. Number 5, we have twice x divided by the difference between x and 5. Now this sounds rather complicated, so let's take our time and kind of work this a little bit at a time. Twice x is being divided by something. Twice x, remember, is a way of saying 2 times x. So our first operation we're doing is division. We have twice x, or 2 times x, being divided by something. We're going to use that fraction bar to indicate what we're dividing by. Now, what are we dividing by? What we're dividing by is a difference. Different means subtract. So I'm going to put a subtract sign down. Now, this difference is between x and 5. Now, normally when you see the word difference, the number that is written first in your subtraction symbol down here. So what we have here is twice x being divided by the difference between x and 5. I might mention to you at this point, when you're writing multiplication or addition, you do not have to be careful about the order that you write things down, because multiplication and addition are both commutative operations. When you're doing subtraction or division, however, it is very important that you put those down in the correct order. You know that if you change the order in subtraction or division, it can change your answer. So you'll want to be careful that as you translate these, when it's subtraction and division, that you put these in the correct order. I have some other examples that I'd like for us to look at that is a little bit different in that once we have the expression written down, perhaps we can simplify it. Let's take a look at those. Translate into a variable expression and simplify. Let's look at number 1. A number plus 7 less than the product of 3 and the number. Now that is really a complicated expression. What are we doing here? Well, let's see. A number plus. Let's stop right there. This is our first operation that's indicated. Plus means that we're adding. Let's see if we can tell what we're adding here. We're adding a number. We don't know what that number is. When we have an expression such as this and we do not have a value for that number, we need to use a variable. So what I'm going to do first down here is to write down x is going to equal this number that I do not know. So using this expression, I will be able to write down an expression for this. A number plus, x is the number, so we know we're going to have x plus something. Now, what is it that we're adding to this x? This is a complicated expression. Let's see what we're saying. 7 less than the product of. 7 less than means we're taking 7 away from. 7 away from a product. So we're going to have a product here. I'm going to put down here in parentheses that product, and then we're going to put that take away 7. 7 is going to be less than this product that we put in here. Now, what is our product of? Our product is of 3 and the number. Remember, x is the number, so we're doing a product, a multiplication between 3 and this number x. That will go inside here. So we have a number plus 7 less than the product of 3 and the number. Now, these parentheses, as it turns out, were not entirely necessary. So we can simplify here. Because of our plus sign, and we understand a 1 in front of this parentheses, I can rewrite this as simply x plus 3x minus 7. And then because x and 3x are like terms, I can add those together. So x plus 3x gives me 4x minus 7. We have written our expression and then simplified. Number 2, 3 less than twice the difference between a number and 9. Let's start at the beginning. 3 less than. As before, this less than means we're taking 3 away from. Now, in terms of the order that we're doing then, we're going to have something over here, and we're going to take away 3. 3 less than, take away 3. So that 3 needs to be sure that it's over here on that right-hand side. Now, what are we taking 3 away from? We're taking 3 away from twice the difference. Twice means 2 times. So we have 2 times a difference. 2, we're going to use a parenthesis for times, and inside this parenthesis we're going to have a difference. 2 times the difference. Now, what is this difference between? The difference is between a number and 9. I don't have anything for that number, so let's make an expression over here. X is going to equal the number that is missing here, and then I can use X in place of a number here, and 9. We have 3 less than twice the difference between a number and 9. Now, how will we simplify this expression? You might recall our distributive property. We cannot subtract 9 from X, so we're simply going to multiply the 2 times each of these terms here. So multiplying 2 times X, I have 2X, and then 2 times the negative 9 is minus 18, and then bring down that minus 3. We have like terms here with these constants, so we need to combine those. A negative 18 minus 3, since these have like signs, we will add and keep the sign. So we will have a negative 21. Number 3. 15 more than the product of 3 and the total of a number and 9. I just noticed a misprint here. That should say number right there. Let me correct that. 15 more than the product of 3 and the total of a number and 9. Try not to panic when you see these complicated expressions. Let's take it slow and easy. 15 more than. More than is one of those words that indicated we're going to be adding. So we're going to be adding 15 to something else. 15 more than, so 15 plus. Now, what are we adding this 15 to? We're adding it to a product. So this product, let me use some parentheses to enclose that. The product is of 3 and the total of something. Well, I'm going to put the 3 here then and use another parenthesis to indicate the product here. Inside here, we're going to have a total, that's an addition, of a number and 9. Let's let X be the number that is missing here. And then I will put in here the total of a number X and 9. We have 15 added to the product of 3 and the total of X and 9. Now, to simplify, we know that we multiply before we add. So we will use our distributive property to do this multiplication. 15 plus 3 times X, and we have a positive times a positive here, so plus 27. And then again, we have like terms here. I'm going to write the variable expression first, 3X, and then adding the 15 and the 27, we're going to have a positive, what is that, 42? Okay, 3X plus 42. Number 4, the difference between 12 and the sum of a number and 8. The difference between is indicating a what? A subtraction. Let's put down our subtraction symbol. Now, this difference is between what and what? It's between 12 and a sum. So we mentioned when it says the word difference, the number that's written first should go first in our expression down here. So the difference between 12 and over here we're going to have a sum. Let's put a plus sign in there for that sum. The sum of a number and 8. We need to have X to represent the number. And then in here we have the sum of the number X and 8. You'll notice I use this parenthesis to indicate that all of this sum is being subtracted from 12 because our difference is between 12 and the sum, not just between 12 and a number. Now, what happens when you have a negative in front of a parenthesis? Recall that you can either just remember that this negative will change the signs inside your parenthesis, or you might want to think this means -1 times what's in this parenthesis. Either way, you should next write 12 minus x minus 8, changing both of those signs. And then combining your like terms here, 12 minus 8 gives you 4 minus x. We've looked at a number of phrases now that we have translated. I would like for us to go to some more problem-looking type problems and see how we can use the information in the problem to translate an expression. The sum of two numbers is 25. If x represents the smaller number, translate 3 times the larger number. Now, the important thing here is to understand that you're working with two numbers that you do not know. All you know is that the sum of these two numbers is 25. Notice he said to let x represent the smaller number. So let's write that down to remind ourselves. X represents the smaller number. What we need to do next is to write down an expression that would represent the larger number. So how will we write down the larger number? Let's go back to this information up here. The sum of two numbers is 25. If you knew, for instance, that one of those numbers was 5, wouldn't you say that the other number is 20? And you would get that by subtracting 5 from 25. So the idea here is that if you know one of these numbers, you would subtract that number from 25 to find the other number. We are letting x represent one of those numbers. So to find the other number, I need to subtract this x from 25. Since I'm saying it in that order, you need to be sure that you write down 25 take away x. X is being subtracted from the 25 to find this other number. Now this will have to be the larger number since x represented the smaller number. Now that we have an expression for each of these numbers, let's look at the phrase that we wanted to translate. We want to translate 3 times the larger number. Times means to multiply. Let's write down the 3 and we'll use a parenthesis for multiplication. Now, this is the larger number, so inside our parenthesis, we're going to write 25 minus x. Now, in this particular problem, we were not instructed to simplify, but do you recognize that we could? We could distribute this 3 and go ahead and do this multiplication and write 75 minus 3x. The sum of two numbers is 32. Using x to represent the larger number, translate the sum of the smaller number and twice the larger. This is similar to the problem that we looked at before. This time, however, we have been instructed to use x to represent the larger number. Let's write that down. X equals the larger number. Now we need an expression for the other number. As before, the sum of two numbers is 32. If we know one of the numbers, we would subtract that from 32 to find the other number. If x represents one of those numbers, we need to subtract x from 32 to find the other number. So 32 subtract x gives us, in this case, the smaller number. Now, let's translate our phrase. The sum of, that means what we're adding. We're going to be adding some things down here. Let's put our plus sign. What are we adding? The smaller number and twice something. The smaller number we have is 32 minus x. Here's the smaller number. we are adding to that smaller number twice or 2 times the larger number. This is the larger number here. 2 times the larger number would be 2 times x. So we have 32 minus x plus 2x. Let's simplify this expression. We can remove the parentheses, and then adding our like terms here, a minus x plus 2x would give us a plus 1x. The sum of two numbers is 18. Using x to represent the smaller number, translate the difference between the larger number and 3 times the smaller number. This is very similar to the previous examples. We are letting x here be the smaller number. Let's write that down. How will we write down an expression for the larger number? If we know the sum is 18, 18 subtract x would give us the other number. So 18 minus x is the larger number. I hope after looking at these 3 examples you kind of have that down on how to find an expression for two numbers when you know their sum. Now let's go to our phrase that we want to translate. The difference between means that we are subtracting. Let's put down a subtract sign down here. What are we subtracting? The larger number and. So we want the larger number as the first one. This is 18 minus x here then for the larger number. What are we taking away from that? 3 times the smaller number. 3 times the smaller number would be 3 times x. Simplifying, 18 minus x minus 3x. Since these have like signs, we will add and keep the sign. I have 18 minus 4x. A car is traveling twice as fast as a train. Express the speed of the car in terms of the speed of the train. When you see this type of an expression in terms of, this means that we want to choose a variable for the speed of the train and use that variable then to write down the speed of the car. So let's begin here. Since he did not instruct us, let's just choose x to represent the speed of the train. Now, if we know our car is traveling twice as fast as the train, twice means 2 times. So the car is traveling 2 times the speed of the train. If x represents the speed of the train, then 2 times x would represent the speed of the car. What we have done here is used one variable to represent both of these speeds, and we have expressed the speed of the car using the variable that we chose for the speed of the train. That's what it means by in terms of. A mixture of nuts contains 2 pounds more of peanuts than cashews. Express the amount of peanuts in the mixture in terms of the amount of cashews in the mixture. Notice in this sentence, we want to express peanuts in terms of cashews. That tells us then that we want to choose our variable x to represent the amount of cashews. Now what we're going to try to do here is to write down an expression for peanuts. Let's go back up here. The mixture contains 2 pounds more of peanuts. 2 pounds more means that we're doing what? We're adding to. We have 2 pounds more of peanuts than cashews. So if we take our amount of cashews, we will need to add 2 pounds to that to get the amount of peanuts. As before, you can see that we have expressed the amount of peanuts using the variable that we chose for the amount of cashews. I have one other example I want to show you in this session. 50 gallons of water were poured into 2 containers of different sizes. Express the number of gallons poured into the smaller container in terms of the number of gallons poured into the larger container. Now, having looked at the other examples, are you sure you know what you want to choose your variable to represent? Think about that a minute. What should x represent? We want this in terms of the number of gallons poured into the larger container. So x should represent the number of gallons that is going to be poured into the large container. Having made that choice, let's go back up here. What do we know? We know that we had 50 gallons of water. Now this 50 gallons would be a what? That would be a total. So if our total amount of water is 50 gallons, and x is the number of gallons that we pour into the larger container, how would we express the number of gallons that would be poured into the smaller container? This is similar to those first examples we looked at. If we have a total, we subtract the one we know from the total. So 50 subtract x will represent the number of gallons that would be poured in that smaller container. And we have expressed the number of gallons in the smaller container in terms of the variable that we chose for the gallons in the larger container. This completes the session on translating just word expressions into mathematical expressions. In our next lesson, we're going to take this a step farther. We're going to take complete sentences and translate those into mathematical sentences. Mathematical sentences means that we're going to have an equation to solve. So if you have completed this part of the lesson, if you simply want to stay on the tape, this next lesson will follow immediately after this next red screen.